Julian, go ahead.
Okay. I'm just going to continue. Just give me a hands up if you need to see this for any longer. Otherwise, just let us know so we can share the link on WeChat. All right, so let's talk very quickly about Makepad, in case you're here and you have no idea what we're talking about. Makepad is a GUI framework built in Rust. This content assumes that you know the basics of Rust. So we're not going to go talking about Rust itself. But as you will see, luckily and unfortunately with Makepad, we don't have to deal with a lot of things that we have to deal with Rust in other frameworks. Like for example, in some other frameworks, you have like an on-click method for like a button in the UI, and you want to say on-click, go and execute this other piece of code, and for that you use a closure, and then very quickly you run into borrowing nightmares. We don't have those kind of problems with Rust, so what you will see today is very simple. As long as you can define your own struct and implement traits, you should be good to go. Makepad is multi-platform with no platform-specific code, so what we will write today, hopefully by the end of it, you can just run it on your laptop. But when you get back home, maybe you can plug in your Android, iOS. You can run it on an Apple TV. You can run it on the web. And you won't have to do anything specific rather than just follow the building instructions. Makepad has its own DSL. DSL is a domain-specific language. Makepad has its own for defining the UI. We're going to be looking at that first. Makepad has a very powerful and flexible widget API. And I mention this because with Makepad, of course, it first offers a set of widgets like a button, a label, list, a drop-down checkbox, etc. But you can also implement your own. And all of that is within the same API. So today, we're going to do very simple things that are going to ignore some of the things like scope and actions and some of the more advanced elements. So you will see that I say, hey, just ignore this for now, and that's because you might not need it until you do something very complex. Makepad has its own IDE, Makepad Studio. We're not going to be looking at that today. If you want to see that in action, you can come tomorrow to Rick's talk, which is going to be an actual presentation on Makepad. And Makepad is in very heavy development. So a lot of the things you will see today might likely change in the future, although Makepad in this last year has become quite stable. So just so you know, if you see some things that are not very polished, it's because we just haven't put as much time as maybe other frameworks that are longer lived. Even though I say it's in heavy development, we've been working on a lot of demo applications and actual applications that we have in production. One of the first demos we worked on is Wonders, which is this kind of clone application of a Flutter application called Wonders, which is an application made by a company that specializes in Flutter, showcasing how to do like all these fancy animations and interactions with the UI. We rebuilt this in Makepad. It's very rich in animations, as I said. It's kind of a demo to show that you can actually do these things in Makepad as well. We also have Molly, which is a LM Explorer built purely with Makepad that runs locally. There's going to be a talk about this in the next generation internet track. I believe it's tomorrow. I don't remember the time slot. So you can look at that. And we also have, oh, sorry, I wasn't playing. And we also have Rubrics, which is a matrix chat client. I believe that's also tomorrow on that same track, the next generation internet. But you can hear a little bit more of how this app was developed. I haven't mentioned it here. I should have included a screenshot, but there's also, of course, Makepad Studio, which is the most advanced application built with Makepad. But again, you can come tomorrow to Rick's talk and check it out. Okay, let's get to building something. I will first show you what we're going to be working on. So if you manage to download the repo, you will see that you have two crates. We have Workshop and Solution. And Workshop is kind of the half-empty template that we're going to be working on. And Solution is the actual almost finished application. So I'm going to go ahead and run the solution. You can do two things. You can cd into Solution, or you can just run it from outside. I'm just going to do this. You can say cargo run -p to indicate the package, in this case Solution. Is that big enough? I think so. As you will see, we'll be working in a very simple fitness, like health tracking / fitness application. Usually you have here a lot of graphs indicating how much you slept and nutrition numbers and so on. I kept it very simple to not overwhelm you with information. And we have a few interactions. So we have this little store section, which is going to bring us to a typical just add your product to cart view. You will see that when I add an element to the cart, it will increase this number. It will be synchronized with the number up here. And it also starts this little animation. We also have the change in color. And of course, you can add more and reset the state. We have, again, very simple example of what like a apps workout view will be, where you have just a big timer. So you can start the timer, pause it, cancel, start it again. And lastly, an even simpler one, which is just a list of items that you can check out and see that you have logged this as done, and it will increase a calorie counter on the left. If we have time at the end, we can add a little animation here with the fire. Okay, so the way we're going to do this is I will start first showing you what the basic application structure for a Makepad application is. And look at the DSL to see how put elements in the UI. Then I will give you some time to complete that first screen. So we're going to be working on the workshop crate. Afterwards, we're going to get into how we make the UI interactive. So we're going to look at the widgets API, how to implement your own widget, how to add state, look at things like events, actions, and animations, hopefully if we have time. And lastly, you can implement one of those screens. We have the timer, and we have the other like workout items tracker. I will give you a base UI template for that, and you can add your own behavior to it. Okay, so let me know if this screen size is all right. So I'm going to go into workshop, and as you see here, this is what the structure for a Makepad application looks like. In the cargo toml, you will see that I just importing Makepad widgets. Currently, we don't have a very uniform mechanism for releases. So if you want to check the latest from Makepad, just pull it from the GitHub repo and check out the branch rig. That's where you will get your latest. Or you have master, but it's a little bit behind. Okay, let's look at the source. Okay, first of all, we have resources here. These are just simple icons, PNGs and SVGs that we're going to be using in the application. And then in source, we have main, the entry point of the application. This will call actually some code that is prop macro generated for running the application. The reason for this is that in different platforms, the entry point is a little bit different. So some platforms require you to have a main function. But some other platforms like mobile or web, the application is like a DLL. We have platform code calling into the Rust code. So you don't have to worry about it. You just write this main, you call into the app. And that is what we have here. App is the main model of this application. The first block that we have is live design, where we write the DSL for application. This, you will see, especially in shaders, looks almost like Rust, but it's not entirely Rust. So it might take some time to get used to it. And the first thing that you will see is that we say, hey, we have this application. When you see the syntax, the double brackets, it means that we're referring to something that is defined in Rust, like an actual struct, which is the same here. You might even see an error if I comment this out. It will complain that it can't find it. And then app main, this is what was called from the main entry point, which is what we'll say, okay, we will start the application, render a loop, and so on, based on this struct. What we have right now is simply a window that has a position and an inner size. Sorry. If you run this, you should see the same as me, which is just an empty window. The position and the size are just hard-coded so that it looks nice on the screen, but you can like play around with this position. I just wanted something that will be right next to my editor. So I don't have to, I don't have to alt-tab as much. Then looking at the Rust code, we have the struct, like we said. We have a widget reference to the UI, which in our case is just a simple window. We have a live register trait implementation, which basically tells Makepad to register these live design blocks. So first of all, we say, hey, import all of the Makepad widgets. And then in this case, I have another file called styles, which we will get to in a moment, which is just like colors and font sizes and so on. So we're telling Makepad to register the live design for that. And you can see I have it imported up here as well. Then we have a match event, which we use to handle actions. We'll get to those a little bit later. And handle events. So here is where we handle all of the events that can reach any widget in Makepad. Events are signals of usually user interactions that come from the platform level. So an event can be something like a finger down on the screen, like a mouse hover, maybe things like resizing the window. And I can actually give you a very quick example of that. So I can handle an event here. We're checking if there was the current event that I'm handling is a key down. I'm checking if the key code is return or enter, and I'm just logging. This log you will see me using is almost like a simple print line, but what it's doing is also sending if you're running, for example, on Android, this will take care of sending this through the ADB so you can see the logs on your computer screen. So this, and here if I press enter, you will see that I get the log, return key pressed. I will look at more at the events later. Okay, let's get to building the UI. So like I said before, we have an empty body. The first thing I'm going to do is give it a color. So we can say, I want to show a background. And then I need to say what to draw. Draw background. And the simplest way we can do this is by putting a color. So we can say, for example, white. And this will draw the body of the application white. And what this is doing behind is, body is essentially a view that we will get to look at in a moment. And we're just overriding properties. Actually, the way that this works under the hood is that Makepad uses pixel shaders for styling. Pixel shaders are small programs that run in the GPU instead of the CPU. And a pixel shader, specifically, runs for every pixel in the screen. So we can actually override that. We can say pixel self. This will return a vec4, so RGBA, for the color of this specific pixel. And I can just say what this says about default, which is just return self.color. So this will return the same. We can say black, return black. But pixels also allows us to do, pixel shaders allow us to do some very fancy things. So we can say, I want a mix of, return a mix of the color, white, but also black. And I want to mix them based on the position of this pixel vertically. So I can say self pos y. And this will give me a little gradient. You can also, of course, make it horizontal. But what this is simplified doing by default is just returning color. Self.color, sorry. What we're going to do for now, to keep it simple, we're just going to use a simple color that I have already defined on the styles. And the way that works is if you want to reuse some code, instead of copy-pasting everywhere, you can just say color background. You can say white here. And then you use parentheses. So you say color background, sorry. And that should work the same. Black. Now, you will see that I have imported the styles folder. And it's basically what I'm doing here. The styles file. I just defined a bunch of colors, some sections, some styling for an image that we'll look at a little bit later, and a text bold, which basically overrides the default font with a bold option. Okay, so let's keep that. And then let's start working towards, for example, I have a screenshot here, so we can work towards this. The first Makepad widget that we will look into is View. View is kind of the foundational building block for the Copilot is drunk. A foundational building block for Makepad. They're somewhat analog to divs on the web, where you just put divs everywhere to set the layout of things. So I'm just going to come here and say, sorry, let's import the right color. Color background, right. Just going to add an empty view. If I do this and hit save, by the way, this is all live reloading. There are some things with live reloading that don't work very well. It's not super stable. So if you maybe move things around and wrap them and then move the order of children, it might not render exactly as you expected. In that case, just close the app and open it again.
I did fix that, I think. Or is it still doing that?
I haven't tested it. I mean, like, I haven't come across any errors. So,
like a week ago.
okay. So I have a view. I'm going to do the same that we did here. I'm just going to give it a background. The background, let's say color white. And say show background true, otherwise it's going to be transparent. And the first thing that you will see is that this takes the whole space. This is because View has walk properties, width and height, and by default they are fill, which means they will take as much space as possible. And this is an enum, so basically we can say fill, we can say fit, which will only take as much space as it needs. Now it's empty, so that will then render anything. Or we can give it a fixed size. The same for height. So let's just keep it full for now and keep it transparent. And let's get to draw text. So for this we have a widget called label. Label has a text property. And here we can write, I think it was good morning. And the first thing you will see that is extremely small and is very high up on the application. So what I want to do is add some padding to the view. You will notice this is quite similar to the box model in CSS. So if I say padding 20 or 40, this will add padding evenly on the whole view. A way to debug this is by saying debug A, as in for all. And this will draw these little lines showing the padding, the margin, and the border. So the space between the border, red, and the green, that's the padding. It's probably a little bit too small. I can add also some margin, if that makes it clearer. I don't know if you can see it on the screen. Margin, sorry, there you go. So you see the space between red and green, that's the padding, and red and blue, that's the margin. So let's just keep some padding for now. You can also specify that added evenly, but you can specify, so you can say I want more padding on the top, 40, then left and right, we want 20, and then we just don't care about the end. And I'm just going to remove this. There you go. If we want to override the styling of text, similar with draw background, we have draw text. We can keep the color the same, but we have another property to modify the sizing, and that is text style. And here we can say, sorry, font size, and make it bigger, 20. As you see in the screenshot, we had another below. So I'm just going to copy paste this label and say GOSIM. Another thing you can infer from here is that by default the elements are being drawn from left to right, and this is because we have another property in Vue called flow, and this by default says right, but you can also make it down, and it'll place it beneath, below. Sorry. You can also use spacing. So you can say the spacing between my elements. Just keep it short. And if we want to further override this one, we can import, so reference the text bold that we had defined in the styles folder. Here, text bold. Can run again. And if we want to make it white, again, the same property color and white. This is the same as if I was writing 6 Fs. It's just repeating the same one when I use only one. Okay, so we have the basics of text. Let's now move on into these little buttons that we have here that look like pills. The way I'm going to do now, just to keep showcasing the properties of view, I'm just going to keep using a view. Ideally, you might want to make this a button, but we're not really going to click it. So I'm going to keep using view. And for this, let's make a rounded view instead. Let's give it a fixed width and height. And then let's put a label here and say daily. I'm not going to override anything else. I'm just going to make the style bold. Oh, what is it up there? Sorry, I put it outside of the view. There you go. That's very small. Let's give it a background. Show background true, and then draw background. And color, I have another imported color that I believe is called color blue. There you go. Another thing you can infer here is the positioning of the elements. So this happens because we have a property in view called align. And by default, this is set to align on the x-axis at 0, 0 and E at 0, 0. Which also means that the 0, 0 in Makepad is at the top left instead of at the middle. If you want to align horizontally, we say 0, 5 and then 0, 5 here. And then again, if we want to make it look exactly like in the screenshot, there's some other smaller properties we can work with, like give it a radius. And we have the color. There are other properties of rounded view. You can give it a border width. You can say 2 and border color and make it white. Okay. I'm going to leave it at that for the pills because we're going to see a little bit later how we can reuse them. And I'm just going to jump right into the view that we have down here. Because we're a little bit shorter on time, I'm just going to go ahead and copy paste it so you don't see me typing for half an hour. Here. And the way we're going to do it is we're going to first define a reusable component called box. So if you see here, box is simply a rounded view like we had just now. Cursor hand, what this will do is that we'll put the little hand cursor and we'll also make it clickable. Otherwise, the click events are not going to be dispatched or solely pressable. It's not clickable like a button. Padding, flow, fill, align, we just looked at those. And then I'm making a little section that has a header like we have here, where we have an image and a label. And then I can go ahead and reuse it. Just like we are overriding rounded view and any of the other elements, we can, we can override box. So we have specifically sleep box. And as you see, it got rendered here. And what we're doing is, hey, we take the same one, override the color, give it a height. Then we're overriding the header. And for this, you might have noticed that we have to give it a name. So I cannot just say, I have this section here. I have to give it a tag. So then I can use that to override that specific part of the DSL. I can, I'm using here a reference to an image. So this is defined in this other file where I'm importing an image. This is a live dependency, and I'm just pointing to what I have in resources. Something to note is that the image didn't show up here, even though it's imported, and that's because Makepad does some tree shaking, so if you are actually not using the image, even though you have it imported, it won't be included in the final app bundle. So if I run it again, no, error. Dependency value none. Sorry, I need to include it in my file because I have not imported the other one. So there, and if I reload, there. Then for the label that we have here, I'm a very lazy developer, so instead of just writing flow down and right everywhere, I made a little helper called section down and section right. You can see it here. It's just simply writing view, flow right, and flow down. So it's a little bit easier for me to read. You're scrolling quickly. What we're saying is we're aligning this on the right side instead of the left side. And then the labels, as you have seen. Okay, so I don't want to bore you looking at more of these properties. The plan for now is that you can complete the rest of this page with the information that we have. And to make it a little bit easier, you can imagine that this can get a ginormous file if we put everything here. So I'm actually going to go ahead and delete everything that I just made. And as you might see, we have included some other files. So we have home, which is going to be our home page, where I have written pretty much all the code that you see on that page. So you have the home header with a good morning message that we saw. The way we import this, just like we have for styles, we're just going to say home. And then we need to make sure we live register. So we say home live design. And then here, we can remove this as well. We can call home. Slide reload. And there we have pretty much what we had before. So the challenge I wanted to give you is that you can come into, again, we're working within the workshop crate. If you come to the home file, you will find everything that I was just working through. We have the box defined exactly as I just had it now. And then I even went ahead, defined the pill, which is this button here. You can reuse it. And then the boxes that you saw. So we have a sleep, nutrition, steps, which are the different boxes that you see here. So your only task will be to come into the main section called home. And within the feed, we have sleep. But here you can include others. So you can just say nutrition box, and it will get drawn below. Again, because I wasn't using the image, it's not rendering now. But if I restart,
we'll fix that very soon.
you'll see it there. So again, just copy pasting these names from up here, and then you can work around with the view properties like width, height, flow down, left or right, to accomplish what we have here. Can get back to this. So yeah, like I said, this box is already defined. You can just grab those and paste them within the feed block. And if you want some more hints, because you're not going to remember everything I just said, if you look at the README of this repo, I have included kind of like a cheat sheet with all the properties that we just discovered. But you should learn how to write all of this. So yeah, just wanted to give you a couple of minutes, I don't know, like 10, 20, to play around with the DSL, and then we continue with adding behavior. If you have any questions so far? I can hear.
Can we add some sound or voice in the button? so we can get some information to go to bed or wake up.
Yeah, I don't know if we have.
We have
Any-
sound APIs, but
Yes.
we don't have it super easy.
Yeah. So Maple has the capabilities, but there's not an easy way right now to do it that you can just like, hey, play this sound right now. You can definitely build it, but we don't have an easy way to do it right now.
Yeah. We can add it though very easily, but we don't have it right now. Makepad has audio APIs on all platforms, but they're very low-level audio APIs. So they don't play in MP3; they play a raw memory buffer. So
I see.
we have to make that easy to play a WAV file. But we already have a synthesizer, so it is definitely already in the code base. Yeah, you can run that.
I can
Yeah.
just to show you an example of audio working. Let's see if I can. I don't know if this will output the audio here.
Well, that's a good point. I'll make a note of it. Simple.
See.
Playback.
So this is one of the first big applications built with Makepad. This is purely Makepad. And using those lower level audio APIs, you have a working synthesizer.
Your volume is off, probably.
No. Maybe I need to choose where I output it.
Headphone port, yeah,
Yeah,
or
headphone port.
HDMI.
There you go.
Yeah, so this is an example application for sound, but I made a note to make a simple one for just a WAV file.
Thank you, thank you. I just wonder something
Yeah.
because I'm first touch this program. Maybe I will be interested in it in the nearly future.
Hey, cool.
Thank you for your lecture.
All right, thank you. Sorry, I'll get back to the presentation so you can see. Oh, closed. Yeah. Mm-hmm.
都下载不了吗？你下载了。哦，刚才一直在网络那个库里面有2个版本嘛，然后有一个是 workshop， 有一个是 solution 是一个完整的版本，就那个 demo。workshop 是一个简易版，你可以就看一下怎么实现那个他展示那个。应该是一次demo phase。
go ahead and finish the file.
Not hard.
You want to make a calculator, right? You wanted to make a calculator.
Yeah.
Because you use it too much.
The problem is that generating takes quite a while.
If you want to do it live, yeah.
Yeah. But maybe I can make it. Notice there's this drop off in those like Julian parameters where it's just not it gets further and further away from OpenAI. But 27 Julian parameters. It's kind of exciting to see that we might get actually working AI.
It's weird what you can have with shaders. It's super useful.
It all depends how detailed the prompt is, but yeah. I mean, I did learn some presentations as well, where I was too excited to fly and couldn't really show the visual designer well.
Then you have, because we're used to using screen.
Yeah, I was
Then
like,
you have
oh,
like
presets made that a big requirement. AI does far more on your laptop. It's a 34, 23 Max.
the screen is beautiful. The screen is beautiful, and that screen, like the screen in that machine is beautiful.
Yeah, yeah. Otherwise, AI is can't even run it.
I don't know how I'm doing it. I have to.
That's why I made the whole AI thing file. This would be ready to go through it or things that went wrong. But yeah, we can go in presentation like make a calculator app and then wait for 45 minutes. creator of the framework, by the way. So yeah, the reason that I wrote Makepad, and that is something that I mean, if you can run Makepad Studio just on your computer, you should be able to just run it. And that is not fully visible yet because it's still work in progress. Is that we are building a visual designer and IDE for this UI. So you don't have to, let's see if it's doing anything.
Oh, I think it's hanging.
Why is it hanging? Can you delete Makepad state maybe or something like Makepad state.run? It's right in that directory.
Let's see.
Just rm makepad _ state.run. That one.
This one? Oh, okay.
Or in your terminal. Let's see if that was it. It has been, yeah, there we go.
Okay.
Could you run maybe Ironfish on the top, middle, down, 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 there. See if it works. Maybe open the splitters a little bit in the middle. Yeah, not that big. The right
Okay.
part is going to be the application.
All right.
There we go. So, and then you go to examples in the tree. In the tree on the left, you go to, no, the middle tree, sorry. You go to Ironfish desktop. Now I just click on the folder. Oh, it's also still overlapping. Okay. Well, I'm going to demo this tomorrow. But the idea of Makepad is that it comes with a full visual design environment and live coding, just like Visual Basic or Delphi or the things that we had. And you can live code and run the applications in the IDE. So if you open, could you close the Ironfish on the left? Just click on the play button for Ironfish and just click it on stop. And just click on simple. And then, yeah, maybe close the design view a little bit. Just, oh yeah, no, you can open the simple app. In the, yeah, just click that one. You can zoom around, just drag it a little bit. I just made that editable, so that is not in the repo right now. But that is the design for that simple application. And if you now go to, if you move the splitters a little bit so you can open the code file. And then open example, simple source app. Yeah, and then just go to that code editor. And then type in like hello world or something, that button. Just type something in the text.
Here?
No, in the button. Yeah, just change the labels. Hey, why is it not live reloading? That's lame. Anyway, I'll demo this tomorrow as well. Like the application can be live edited. Can you click play and pause on the simple one? Yeah, okay. I don't know. Live. Wait. Yeah, maybe your WebSocket IP is wrong or so, because the child application connects to the IDE. Either way, the unique part, what we're still working on, is that these applications will be designable in a designer-friendly environment. And I've recently added also AI support. I'm going to show that in my talk tomorrow as well, so that you can ask the AI to, yeah, I think the application crashed. Just start it again. No, not the IDE, but the inner application. Simple. Yeah, I mean, I did 1 million fixes just over the last couple of days. Yeah, so the idea is that you have a visual design environment, a code editor, everything is live, and you can ask AI to design the UIs for you. So I would say that is our primary unique angle, but it's still work in progress. And beyond that, the framework is also very good at high performance. So the whole IDE and all of those applications that are in it are written in Makepad itself. So the IDE is also a Makepad application, which is in my experience, a complicated and difficult thing to build in almost any UI framework. So this is my test case that maybe you can show the code folding.
Oh, okay.
And just open a big file. Yeah, and press escape. Press escape. Yeah. So you have code folding, and yeah, it has a lot of high performance features so that we can build the design tooling and the tooling itself in its own framework. So the application that Julian was showing is kind of a very simple. Maybe let's see if we have another interesting one. I mean, Ironfish is the most interesting one, but maybe you can click Studio. So I am using Makepad to build Makepad. So Studio runs as an application. I hope. Is it compiling? Where is it going? Could you scroll to the end?
Oh, I just probably
you broke it?
something here.
Yeah, there we go. So I am using Makepad to develop Makepad like this. So I'm live coding and developing the IDE in the IDE. And yeah, so I know it scales, I know it works. What we're doing now is making sure that it's very accessible and simple also for the simpler applications, like the example that Julian was working on. So yeah, I would say the unique angles are enough performance that it scales all the way to full design suites. And yeah, hopefully we can make it simple enough that people can also make mobile applications in this design environment. Does that make sense?
Would you like to provide some example to show how to AI help us do some works or do some project?
Oh yeah, so Rick is going to make a presentation tomorrow. You can see that tomorrow.
I made that only a week ago, so I'm showing what I made tomorrow with AI.
I'm sorry. Tomorrow morning I have an important meeting in our company, so I will go maybe afternoon.
Okay, well, I can show you now.
Okay. Yeah.
他现在就跟我
Oh. Oh, wow. Okay.
真的有个会上午来不了。真的是 petition.
So I've been making this. I was just making this actually. Oh. Looks like the DPI needs to restart. Oh, I broke it. Hold on. Letting the AI break it. So here we have a simple example with 3 buttons. I'm also going to show that you can now edit the UI by dragging items. And yeah, it's easier. Sorry. And yeah, we have a local AI model. Let's see if I can run this. Oh, it's red. That's a bit bright. Let me make it not red. Here. Right, so we have, this is AI generated code. I'm running it on a local model. So I can press return. I think I can show you with the fast model probably. Hard to see the screen. Oh wait, I have it on my own screen, of course. All right, so let me start I'm using the Quen 2.5 model. And then this is what you can expect with AI generation. On a local, this is a 16 gigabyte model, so now the AI is generating the test application. And it should, when it's done, immediately update the output. So you should be able to see UI here change dynamically. It's recompiling now. Probably made an error. It made an error. I'm trying to teach the AI to write this code correctly. Let me see what it made as an error. Button not clicked. Oh yeah. Don't pass CX as argument to clicked. I have to correct the AI. I'm still trying to figure out how to make it do this with no errors. This is also a fast model, so as you can see, it generates pretty quickly. That means also that it gets more lossy and it makes more errors. See if it got the hint. Yeah, now it generated this application from scratch with live editability. So yeah.
So what's the command? I mean,
The command.
on the beginning.
You mean the prompt? This is the prompt. Write an application with 3 buttons vertically centered that prints a message when you press the button. As you can see in the log at the bottom, it is printing the message. So it has generated the DSL and the Rust code. And then we can design it live. But it's all work in progress. But that's what I'm going to show tomorrow.
So is it possible that we use this model to not pass very professional or domain specific, for example, CX? I don't know what a CX
No,
means.
I know. I'm still fine-tuning the model with the context window so it doesn't make errors. But what is so is that the small models that run locally make much more errors than, for instance, cloud models like OpenAI or other AI big models like Claude. They are much better, but I wanted to show it running locally. That makes it more error-prone. With OpenAI or with Claude, I had 80% success rate, so it is much easier to get it to write working code.
Oh, thank you. What I mean is that I want to use your model.
Yeah.
But I don't know how to ask the right question.
No, so this is not this is just Qwen 2.5 coder. There's nothing else. It is just that model. It is not specialized for my code. I am just telling it what it does wrong every time, and then it fixes it. So I have this file here called AI. Hold on. AI markup. And here I tell it these things. So don't pass CX as an argument. So I just put that there. I just put it here in my document. And as you see, there's a lot of instructions here to correct the AI when it makes a mistake. And that seems to work. But yeah, it's not flawless yet. That's why it's a work in progress. See what it does now. Yeah, so now I didn't have to put that instruction in the prompt because I put it in the context.
Awesome.
Right?
Yeah, it's better than what I can wrote in seconds.
Yeah, it's not bad, right? It's pretty amazing that AI can already do this.
Yeah, that's wonderful.
Make the background dark gray and add a slider. It's a little bit of a slot machine, as in you don't know what you're going to get, but I'm already impressed that this runs on a 7 billion parameter model, which is, yeah, I think now it's making mistakes. See, now it's starting to put code in the DSL that really shouldn't be there. So now it's not going to run. Give it another go. I can also pick a slower model, like that's much closer to, that's a little bit closer to the cloud AI providers. So let's see. It's going to take a lot longer. So let's do one button and add a slider. I can also make it only generate the UI DSL, which is also even faster. So I can set this is the AI window. I can set the context to Makepad UI, and then it will only generate the DSL. So it won't try to generate the Rust code. It makes different errors in the DSL than in the Rust code, but as you can tell, this bigger model takes a lot longer to load up the context. It's still loading up the context. It'll start typing out in a few seconds. Okay. Let's see. Yeah, there we go. And as you can see, it's also generating the code in a slower way. But this model is more accurate. It just looks less nice to present it on a screen when it's going at this speed. Yeah. So I've been trying to make the small model good enough. See, there we go. Now it only generated the UI. Yeah, anyway. Yeah, I hope this is going to be the future way of interacting with our stuff, that it's much easier to get started with the application and with templates.
Is it possible that when we connect to the cloud AI that we can use Chinese or other languages to pop up the questions?
I think it will already accept Chinese. I don't see any reason why you can't type Chinese to it, because the model is multilingual already. So I think I made the text input do Chinese. Hold on. It'll generate the text in Chinese, I'm sure. Let's see that. System settings. I have no idea what I'm going to now type on my keyboard, so keyboard. Input sources. Chinese. Chinese. Simplified. Add. Done. Where's the show in? Why is it not in my top? Why is it not in my menu bar? There's supposed to be a keyboard. Oh wait, it only shows when I'm typing. No, anyway. I don't know how to type Chinese when the key. Hmm?
I can help you type Chinese. I think it added a handwritten version instead of
Hmm?
I think it added a handwritten version. So see, it says
Oh, the handwritten. Oh, that's not good. I need the keyboard input. So that's then traditional? No. Simplified. Oh, Pinyin? Oh, okay, sorry. There we go. And then I can do... Can somebody type something not accidentally offensive?
okay.
Yeah. Is it not working?
I don't know.
Hold on. I just need some characters. Oh.
Not type the things I want.
No, I can tell. Okay.
The Chinese alphabet?
No, I don't know. Maybe I didn't set the right font on the text input. Okay, good point. I'll fix it. I'll fix that. Yeah, I didn't do the right font fallback. Okay, I'll fix that later. But yeah, it should just accept Chinese. But
Maybe you can just translate it into Chinese and then copy it to that.
that might work.
Maybe you use the wrong.
Type something. Maybe I can cut and paste it.
Chinese?
Yeah, just type hello or something in Chinese.
Oh, that's fine. That works. Okay, I will try to type C.
No, I have to fix that because we have to write our own handling of that, and I apparently. Yeah, just I pasted it. Yeah, just type it here, and I'll try to paste it. Hello. Okay.
So in the bottom right, color to right.
Okay. Okay, hold on. One button. Ah. Okay. One button. Let's see. Sorry about the text input. I thought I tested it. It worked for rubrics. We are going to find out. Yep. Well, it's turning the background to red, yes. So, that's not of my doing, that's just the magic of AI models. So. All right. Julian.
Is there have document? DSL. Document.
Yeah, we have some documentation on that as well. Like it's pinned in our Discord. Can you maybe share the link somewhere?
I can share it at the end.
We now add some documents in the this component, but we now have we don't have a document for DSL. I'm just writing. I'm just help to write the document, so don't worry. It will generate. We'll make that.
In progress, yeah. Also, we're going to get a lot of help from AI now in providing more documentation. Because we're better at writing code than documentation, but AI is really good at writing documentation when you've written the code. So.
其实大家比较关心的应该是那个为什么要用 Makepad 而不是用一些其他的像 JS 系列的一些框架，比如 React and Vue 这些框架，对吧？那其实刚刚 Rick 他展示的是我们Makepad Studio 这样Makepad Studio 上面它这样的一个强大的功能，它可以用 AI 去帮助生产一些组件或者是页面。它也可以在Studio 里面进行一些非常复杂的工作。那其实比较核心的一个是我 Makepad 的一些特色。那例如它是一个跨平台的，像如果说是 Web 端的一些框架，它可能要借助一些其他的应用，其他的框架或者是一些东西进行跨平台处理。比如像 Vue 它并没有像它能支持桌面端，它可能 Vue 支持桌面端的一个方式是像 Taro 去或者 Electron 去扩展它们，对吧？但是 Makepad 它是直接支持跨平台的，所以说你可以在桌面端嵌入式或者是一些手机端去写同样的代码但是它可以写同样的代码，然后编译到不同的这样的一个平台上面。还有一个就是Rust 语言带来的一个平台带来的一个自身的语言优势，在性能上面编译的速度，包括它的一个在像 animation 一些动画和一些绘制上面的一些带来的性能的提升。这些都是 GS 可能会遇到的一些瓶颈然后包括那个其实 Makepad 它对那个使用者，虽然它要求使用者的一些水平会比较高，但是它也会带来一些更强大的控制，因为它是可以直接去写 GLSL 这些一些底层的东西的，所以说你可以发挥你的想象力，去绘制一些你想要做的东西，而不是非常提供让那些像 GS 他们提供一些非常基础的组件去一点点去做。当然，我也在做这方面的事情，会面向一些水平比较低一些的开发者。我想这些就是 Makepad 带来的一些优势。
Hey, Rick. I was wondering that do you notice that there are some product AI IDE on the internet like Zed or Corsair? I was wondering like what's the difference between maybe your studio or with that or some innovation you make in the studio?
What's the difference with other?
Zed or Corsair? As we know,
Zed, yeah.
yeah, Zed
So
is also implemented by Rust, maybe GPU render, I guess.
Yeah. So Zed is a general purpose code editor. Their focus is to be like VS Code for everyone, Python, PHP, Rust. Our focus is to be an IDE for Rust and UI design. So the focus is very much on having the application in the IDE, live reloading, and with a visual designer, with a focus on Rust, and then integrating AI. So we're focused on a different space.
Different user, I guess.
I guess, yeah. We're not trying to get everyone to use Makepad Studio to write their code. We're trying to make it a usable application design environment. So it's a different kind of thing.
Like a design or product, career, you can use Studio to just build their application very simply.
Yeah, that's the idea. Yeah. It's more like Xcode for SwiftUI. It's more like Xcode for SwiftUI, but then for Rust with our UI framework. So it's a specific focus.
Got it. Thank you.
All right, we can very quickly wrap up.
Hold on, Julian.
Sorry, can I ask what is live node in the Makepad?
Why is live node?
Yeah.
So the DSL of Makepad is essentially a dynamic data structure. And live node is the data value for that data structure. So it's like live node has a ID. It's like a key value pair. Live node is a key and a value, live value. And those are the primitives that the DSL is turned into. So the parser for the DSL and the processor for the DSL only outputs a vector of live nodes. That is the data structure for what the DSL is turned into in Rust space.
When do we use it?
Ideally, you don't really have to touch it. But if you do advanced things with the UI and you make UI components, then you will run into it, yes. Because you will see that live apply and all these things use live node, because this is where the DSL is turned into Rust values.
What about before apply and after apply? What was?
Yeah, so apply just means take this piece of DSL and store it onto your Rust object. And so you can have code you want to run before that happens, and you can have code that runs after that happens. Often the after that happens part is where you do construction of things, like you construct internal values or derivative values of the DSL structures. So it depends. Before apply, you can, for instance, clean things up that you need to, because the live reloading of the UI needs sometimes special handling for particular widgets, and that's where you do that often. So for lists, if you get a list and you get a new piece of DSL that you live edited, what it has to do is that it has to send every instance in that list the new DSL, and that's what you do in these functions, the lifecycle functions of the DSL system.
Okay, thank you.
You can keep going, Julian.
Okay. Yeah, let's just quickly wrap up. If you don't get to finish this, don't worry, because that's just an excuse for you to try out Makepad. As you see, what we have here is very simple. So we have first a wrapping section right, where we have these elements, nutrition and steps on the left, and having habit tracker and workout on the right. And then they're just separated by a section down. So we have up and down for both sides. Just gonna reload so we get the images. And I'm actually gonna go ahead and copy the full home from the solution, just to speed things up. You have it complete. And let's just very quickly get into how to add some interaction to this. So what I want to do is that when we click on the last element, this little store section, we get to navigate to another view. So I'm going to go back to my app. I'm going to import what we have here, which is the product screen. I'm going to say product screen. I could just be importing, I'm just lazy, so I'm using asterisk, but I could write the whole product screen there. And then we live register it. Product screen. I'm gonna have to kill my application for this.
Yeah, so the live registering stuff is very important. That is because live design blocks are in your Rust code. Normally, this is kind of a different language that is in live design. You could put that in its external file and it would just work fine as well. The reason I put it in the Rust file is so that it can live inside your Rust module structure and you don't have to worry about if it's an external file. So this is why these register functions are called, so that the Rust application knows where these blocks are. And I don't like that you have to do that, but it's unfortunately the cleanest way to do it.
Thank you. Okay, and if you want to just quickly check that it's working, I can call here product screen. There you go. And we, of course, want to programmatically be able to switch between these two. So what we're going to do for that is use a widget called stack navigation. And stack navigation, what it allows us is to define a root view and then define different sub-pages that you can navigate to. Especially useful for mobile because you have like a literal stack between screens. So I can just say stack navigation, and we can say we have a root view, and my root view is going to be home. So that should work in the same way. Yeah, we have the same. And now we're going to go ahead and add a product as a sub-view. It's a little bit verbose to override the title, so I'm just going to copy what I have here. Let's see. So I'm going to give an ID to stack navigation so we can query this later and check for actions. Root view home. Then I'm going to say I have product screen, which is a stack navigation view, which is one of the views that we can navigate to. And what we're doing here, you're going to see it now once we work on the weird indentation. There you go. You're going to see that we're overriding the title of the view once we navigate to it. So we have the root view, we have the product screen, and now what we want to do is whenever this section is clicked, or is pressed rather, we want to do navigation. And for that, we're going to look into actions. Earlier, I was saying that events are signals of usually user or platform events or interactions that happen. Actions, similarly, are signals of usually state changes within different components of the application or widgets. So you can have an event from the video player that says video playback is ready. You can have an action with that, or you can have an action to request a state change. So we can tell stack navigation, please navigate to this other view. Similarly, we can ask a button if it was clicked, or a view if it was pressed. So we're going to do that. If we look at the home, in this store section that I had at the bottom, store, we have a label, which is what we have here. And then we have this store section, which is the actual view. You see that the cursor hand makes that I get the little hand when I'm hovering. Can make clear that it's not including the text. You see the debug there. I want to basically check whenever this is clicked. So in my application, I can say, first let's use this, where unused. We can say, let store section, and this is self. Within my UI, I want to look for a view, and the ID is store section. This is a macro, it's not a string. And this will return a view ref, which is the specific API for the view. So by default, even you will see now when we create our own widgets, we will get a widget ref, which is a reference to the widget. This can be empty, so it's not an option. Similar to, like, I don't know if you got to ever shake query, like if you query the document and you get something empty, you can perform the actions, you will not get an error, but just nothing will happen. I will actually here get a log if I look for something that doesn't exist. So if I simply do this, I think I won't get any errors. But if I look for Mudeng and I try again, it will say that it performed the query and it didn't find what I was looking for. So it gets back to store section. And now we can say if there was an event, we actually don't care about the contents of the event itself, we just care that it happened. In store section, and we're looking for a method called finger down. So if finger down happened within this set of actions, we can say log store section pressed. So the difference between finger down in a view or clicked in a button. Clicked means that you first press down and then you release. So it's the combination of the two interactions. Press down is just when you first click it, when you first press it. So if I do this and I press here, I will get store section pressed. And the only thing we need to do next is make sure that we are sending the actions over to the navigation that we define here, and then we tell it to navigate to. Just gonna quickly copy this. So it's just slightly different naming. So navigation ref, the same. I'm looking for a stack navigation that I defined here with this ID. I'm telling it to handle actions. Then I'm querying what we were looking at just now. I was calling it a store section, a reference to the store. If it was pressed, I'm going to send an action. I'm saying, hey, I'm sending this action from the app, from the UI, using the widget ID. This path is telling where this is originating. In our case, we're at the root of the application, so we should send the default path. And then the actual action, which is stack navigation action, navigate to, please navigate to this ID, which is the ID that we have here. So if I did everything right.
Why are you doing it as an action and not as an API?
We actually have that too. It's just,
Not idiomatic as far
yeah.
as I'm concerned.
So Rick was saying, why are we doing this as an action and not as an API? And that's actually a good question, because we could have, based on store ref, first let's try if this is working. So here I get navigation. You see that by default we have this little animation where the next view slides into. And then by default, we also get a button back. Whenever we press it, we go back to the root view. Rick was asking, why do we send an action to that widget where we can actually just access its API? And actually just forgot for this example. We could do something like store ref, and I think it's, no, not store ref, the navigation.
Yeah, it's just query it by ID.
Navigation ref show stack view by ID. Let's try it out. It should just work. Product screen. Yeah, there you go. So this is a little bit more direct because we already have access to this ref and we just can talk to its API. What I was doing before is I was sending this action that then was going to be handled within the handle actions block of stack navigation. I think the reason that I went for the action is that in the bigger applications like Rubrics or Moshing or Wanderers, sometimes you are very deep nested in some part of the UI, and you want to send an action for something to happen, to navigate somewhere else in the application, and you're very deep down, so you don't have a direct reference to the stack navigation. So if you send the action, it doesn't matter where the stack navigation is, it will always receive the action, and we'll be able to handle it.
What I usually do in that scenario is I make an app action, I handle it at the root.
Yes.
There you can query it, and there you use the API.
Right.
Which is a little bit more verbose, but then you have a clean route, right? You don't have cross routes everywhere.
Yes, exactly. And we have, since we're here, I can give you a little example. So Rubrics, this is the matrix check client that I was showing earlier. We actually do something very similar. So we have a lot of files, very deep in the application. Someone can say, hey, I want to navigate somewhere else, or maybe a room was selected. And within the app, which is at the root level, we dispatch the actions to navigate somewhere else. So you have a little bit of indirection there.
Also, you should use the bare action API because you're not using the UIT in the path. Right? So just action and just remove the rest.
Okay. Okay, and then let's just very quickly, because we're close to time, let's just make this little interaction work. And the way we do that is by implementing our own custom widget. I'm going to go quickly show you the product screen. So we have the main product screen. We have this little pixel shader, similar to what I showed earlier, just a smooth step to make the gradient smoother. We have a view with the cart up here. Of course, the big image. Around the view at the bottom, where we have text, and then finally these buttons that we want to interact with. So we have the decrease button, this little counter, and the increase button. So the way we can handle this is just like we did right now with the handle actions. And for that, we can make our product screen a widget. And the way we do that is saying, hey, you are now referring to a Rust struct that I'm going to define up here. Down here, you see that it's already complaining that I don't have it. And we can just say struct product screen. We're going to deref live because this is part of the live design. This is an element there. We're going to implement, derive live hook. And this is where someone was asking earlier about the different hooks you have after apply and after startup and things like that. Derive, sorry. And then widget, which is the actual widget API. This will complain because a widget needs to know how it can draw itself. And the simplest way, again, as I was saying earlier, there are many ways to implement a widget, and you can access pretty much all the lower level primitives for drawing within a widget. But the easiest way to do it is to deref a view. So we're saying, hey, we just have a view and we're wrapping some behavior around it. So I can now say deref view. This will tell the widget that whenever it needs to redraw, it will just simply redraw the view. And then we can add a counter, because we want to have some state. We have to decorate with Rust, because this is not part of the DSL. If I wanted the counter to be part of the DSL, you can say something like live, and then put counter here. And then you could access it within the product screen as a property, just like we're doing with width, align, spacing. You could say counter here. But we don't want to do that. It's just a state that we'll handle from the Rust side. So we'll say Rust. Another cool thing that we have here by saying deref is that the elements, like the contents of view, are being flattened within the product screen widget. So you don't have to do something like write view here and then put all these properties inside. Whenever we put width, align, spacing, or children, they're going directly into the view. And then finally, we just implement the trait widget for product screen. and we'll simply have to implement two methods. The first one is handle event. And just like we had in the app, what we're going to do here is send the events over to the view. Handle event. And then draw walk. And it's the same. The view already know how to draw its children, so we just tell it, hey, you can go ahead and tell the view to draw. This is the autocomplete. Get it wrong, so CX2D. And this is returning a draw step.
Yeah, and walk is not the reference. There you go.
No?
What is it saying and what is the error? What's this type signature?
Let's see if I can get the autocomplete, the actual draw walk.
Is this a Rust analyzer or is this AI?
This is it's Rust Analyzer, but I think maybe I have some autocompletion by AI that is messing with the. Let's see. Product screen.
Yeah, it's CX scope walk. So scope comes before walk.
Okay, so the order was wrong.
Yeah, the order was wrong.
Okay, so this is the correct signature.
Yeah.
There you go.
There you go. And then the other one you have to flip as well.
Here.
Must be AI because
Cool.
it can't be Rust analyzer.
No, Rust Analyzer should get it right. It's the point where the AI actually becomes less useful than the simple completion. Okay, so by having this, I'm not using the counter, so this should work exactly as it was working before. There you go. And of course, this is not going to do anything. And here we can just check for events like we were doing before. So we can say they want to handle actions. Like we did before, we're going to call self.matchEvent. And this will take CX and the event. And then we can implement the trait. Huh?
And scope as well.
And scope.
Yeah, because you use a match or widget match event, which is a different
Equal match event for.
widget match event.
Oh, I was using just match event.
You can, but then you lose the scope. But match event also works. Yeah. Okay. Yeah, you're right. You can just use match event, but if you want the scope,
If you want the scope.
true, you need to use widget match event.
Okay. And then we should say handle actions.
Yeah. Yeah.
Okay.
See, now you get the scope. That's the difference.
Since we're mentioning in the scope you can pass data down to other widgets when you're drawing, and they will receive it just like here in the draw walk in the scope, in handle events, or in handle actions. And in scope you can put props, which are kind of like props in React. You just pass values downwards, and they are immutable. Or you have data, like two different fields, props and data. And data, it's immutable, so you can send it over and anyone can modify it. So some kind of like global state that you have within the scope. And within the handle actions, we can now query our buttons. So we have the increase button. And you will see this is behind multiple layers of components. And if we had multiple IDs, you can write the path. You could say something like self.button ID. You could say some view button group increase. But as long as you don't have any problems with having duplicate IDs, you can just call increase directly. So I'm just going to say if self.button increase, clicked actions.
Oh, I think I called the method widget match event also. Instead of
Right.
Yeah. Sure. Yeah.
We're going to increase the counter, and then we can just update the label and use the counter to update the text. So let's see, set text, and we can just say.
Yeah, does it take CX?
Yeah, I don't know why it's doing that.
So if you do set text and redraw, then you need CX.
right, to string. So I can call redraw here, and this will update the counter every time we press. But we can also, like Rick was saying, we can do this at once by saying set text and redraw. And this will take CX because it needs the context to be able to draw.
And the reason that redraw is explicit in all of Makepad is because you can do these APIs as well in the redraw flow. And if you do accidentally do a redraw in the redraw flow, the application will keep redrawing and use a lot of battery on your mobile phone. So that's why it's explicit.
Okay, and then just because we're close on time, I'm just gonna copy paste the rest so you don't waste a lot of time typing. I can show you how it will look like. Let's go here. Solution, product screen, and right, I put it somewhere else. Let's do the following. Let's just replicate this quickly for the decrease button. Decrease, we should say equal, and we can say self that counter -1.
Yeah, you could use saturating sub.
Yeah, but that is if I have a U size, right? But it doesn't overflow with
No, saturating
I33.
sub 1 will stop at 0. Self.counter dot saturating sub 1. You already saw it. Saturating sub 1. So this stops at 0. Very handy. Only
okay, I thought it was just with the overflowing.
No. Underflow as well. No.
No, because if it's U size, then it will overflow. But this doesn't overflow, so it just goes down.
What is the type? I32.
I32. Yeah,
Make it U32.
we can make it a yeah, or a U32.
Ah, okay. Well, it's good to know. Now it should stop.
Yes. Okay. And then I'm just gonna very quickly, just to make it quick, I'm gonna explain how we can add the animator, but instead of copy pasting, I'll just show you how it's implemented in the final solution. So if we run it here, you will see a couple more things happening. So the moment this increases, a couple of things. First, the label with the number changes from black to white, and the background red changes to red, and then we start the little animation. And the way we do that is in our product screen, we're still checking, of course, for the actions on the buttons when they're clicked. And then we created a new separate widget for the cart. So if you remember, we have the cart up here within this view cart. We didn't look at it before. And this is simply this yellow background. The image, which is a rotated image, which means that we can specify a rotation angle. And then this little cart bubble, which is simply the label wrapped by this view. So what we did is we made cart its own widget. You will see that we have it here. And we have implemented, like I was mentioning before, by default, for implementing, for deriving widget, you get widget ref. So in our case, we created a widget called cart, so we get cart ref. And whatever methods we put here, then we can access by querying cart. So back in product, we can look for the cart in the UI. So we say cart, the ID is cart, and we can call update product hunt, which is a method that we added here. Now, like I said before, you can or cannot find it in the UI, so we need to do this borrowing, see if we can find it.
And the reason it's optional is because Makepad is designed to live edit the UI structure, and if we don't make these things fail silently or not fail without a panic, means that every time you make a typo in the DSL, it will crash your running application. So that would break live coding it.
Right. And then what we can look at is of course, as you see here, we're just updating the background. So we're making the color red. So if the new count is higher than 0, we can use apply over. And apply over basically allows us to just introduce new DSL that will override what we had before. So if we go look up here.
Only values.
Only values. We had this white background in the card bubble. And what this is doing is just simply overriding the DSL. And we're doing the same for the label, otherwise it's a little bit unreadable. And then lastly, quickly, we can take a look at the animator. We can add a new animator to the widget by annotating it. You can call it here whatever you want, but you need to annotate it by animator. And then this allows us, within the DSL, to define different animation states that we can use. So I made a shake state, which then splits into two. We have the initial state. I will explain this forward here in a moment. But what we're saying is similar to the apply over. What we're saying is whenever this animation state goes active, we're gonna override some DSL. So I was telling you a little bit before that this is a rotated image, which means we can override draw background and say rotation 0.5. These are arbitrary numbers now. We should actually make it, just use the angles. So you see here this has rotated, and 0 is the initial. So what we're saying is in the initial state, we just want to have rotation at 0. And whenever the shake is on, we want to have a loop. In this case, a bounce loop, so it does the animation and then it repeats on the way back. It will last 0.5 seconds. This is the value of the rotation that is going to end. And then what we change in the apply is the rotation angle of the image draw background. We can, of course, play around with these values. And the cool thing with the animator is that now I'm changing this, but you can modify any other thing. Like you can change the radius, you can change the padding, because you're able to, within the animation, just say, change the padding or the margin or the radius and move things around. And the way we're making it work is whenever we're updating the product count. Remember, we're calling this when the buttons are clicked. If we have more than one product, we want to play the animation. So we call inner animator play, and we just write the ID, the path to the state. I'm checking here if it's not already in that state. Otherwise, it will try to restart the animation constantly, and that will cause lag. And then if the product is 0, or at least less than 1, we just go back to the initial state. One last small thing, this forward that we have here is just to make it go back smoothly to the original state. I could say something different like snap, and that will cut from one state to the other. So if I do this, you will see that whenever I stop it, it just kind of jumps. So instead I say forward on 0.5 seconds, you will return to that initial state. A little bit more smooth. So there, and it gets to go all the way back down. So that's it for the product screen. Then again, we ran out of time, but my plan was to give you some time to work on the other screens that we had. Like I was showing earlier, we have this little timer here. I put some instructions in the README in case you're curious and then you want to try it at home. Makepad has a very simple API to use a timer because you need to keep track of the time. And then you can like add animations, like you can make it blink when it's ending or change the color as soon as it's progressing. So that's like very simple. And what we have here is just handling the clicks of the buttons. Yeah, so I'm just...
You could show it compiled to WebAssembly.
We can do that. We can say, which I promised earlier.
Cargo Makepad WASM.
Cargo Makepad.
Yeah, WASM.
WASM run.
Run minus
P, and then solution. Let's do a release.
work. It should also start a web server.
Yeah. So what this will do is instead of compiling natively to run on my Mac, it will compile for WebAssembly, and then it should start a server and also bring up my, I don't know if it brings out the browser.
No, it doesn't bring browser out, but you should open that URL. Arc browser, huh? Is that based on Chromium?
Like, yes. So you see, this is running on the web. It should work in the same way that we had before. Of course, the sizing is a little bit different because I had a hard-coded smaller window. And in the same way, it's going to take too much time now to set it up, but in the same way that we said WASM, you can say,
Android, right?
You can say Cargo Makepad, Android run, and this will look for the default device that you have either connected, or you can run it on a simulator. And the same for iOS, and yeah, everything else where you want to run it. Yeah, sorry about the time. I don't know if you guys have any questions. Otherwise, that is it for today. And if you have any more questions later, or wondering about anything else, like we said, a lot of things are still being worked on. Documentation, for example, for the DSL and other parts of Makepad. If you want to be up to date with those things, you can reach us out in Discord. This is the Discord for the Makepad channel. I should have put QR codes here, I'm sorry. And then we have a Robius public space on Matrix, where you can see Makepad, where you can see also conversations around moshing, rubrics, and the other applications that are being built with Makepad. So you can reach us out there. Thank you.
没有问题的话就结束了哈。